Everyone, welcome back to Easy Taleem. In the previous lecture, that is last week on Thursday, we learned how to differentiate almost every function Cambridge can throw at us. We did the power rule, we did the product rule, we did the definition of what a derivative is. But today we are going to learn why differentiation even exists. Because Cambridge almost never asks you to just differentiate. Instead, it asks you, now that you have differentiated, what does this tell you? That is where students start losing marks. Today's lecture is probably one of the highest scoring lectures of the entire P1 syllabus, because once you master applications of differentiation, you'll notice that optimization, tangents, normals, stationary points, even many mixed questions are actually the same idea wearing different clothes. So today we are going to connect everything together. So let's begin. What we are going to be learning today is that we are going to do the stationary points, the maximum and minimum points of the curve, the nature of those turning points, whether that's a maximum or a minimum, the tangents, the normals, whether the function is increasing or decreasing using the rules of differentiation. We are also going to learn optimization, the related rates, and Cambridge mixed questions. So if you've completed the previous lecture, then today's lecture is where mathematics actually becomes fun. All right. So what really is a stationary point? So if I draw a cubic curve like this, let's say this is a cubic curve. It looks like a sine curve. So, okay, let me draw it like this. Now, let's say that this is a cubic curve. So you can clearly see that there is a maximum point here, right? Or rather, look at it like this. So you can clearly see that there is a minimum point here and there's a maximum point here, right? So it turns, right? So that's true, but mathematically that's not the important thing that we are studying. The important thing is that for one tiny instant the graph stops moving upwards, as you can see here. So the graph was moving upwards here, and then as soon as it reached this point, it starts going downwards, right? And similarly, it was going down, and at the stationary point, it stopped, and then it started to rise again. So what does this mean? So at these turning points, the tangents, if we draw the tangents, they're going to be perfectly horizontal. Okay, so this is what the tangents are going to look like if I draw them at the stationary points. Now, this horizontal line has gradient what? So what is the change in y over change in x? So the x is changing from here to here and x is changing from here to here, but there is no vertical change. So our change in y is 0. So our gradient is going to be change in y over change in x, which is 0 upon whatever the change in x may be. So the gradient is nothing but 0. So we say that dy by dx at stationary points is equal to 0, right? Now, this is the real definition of a stationary point. I will write it down here as well, and I want you guys to note it down as well. So, at the stationary point or the vertex, dy by dx of a function is 0, right? So, I want you guys to make a note of it, and we have proved it as well, right? Now, it's not just a turning point. A stationary point simply means that the derivative equals to 0. This thing, dy by dx is equal to 0. Now, whether it becomes a maximum, minimum, or something else is something like this as well. A point of inflection, which we are not doing. So a maximum point is like this. A minimum point is like this, that you have already done in quadratics. Now, whether it becomes a maximum or whether it becomes a minimum, we are going to decide that afterwards. That distinction is extremely important. So let's do an example. Let's say that you have a function, a cubic function, x cubed minus 6x squared plus 9x plus 5. Now let's find the stationary points. So for stationary points, a very important condition is that the derivative is going to be 0. So where is the derivative actually equal to 0? So let's find the derivative first. So that's going to be equal to 3x squared minus 12x. Oh, sorry, the function was plus 9x plus 5. So yeah, minus 12x plus 9 equal to 0. So I can factor 3 out. So this becomes minus 4x plus 3. So this becomes x squared minus 3x minus x plus 3. So this becomes x minus 3 minus 1 x minus 3. So dy by dx is equal to 0 at 2 points. X is equal to 1 and x is equal to 3. At both these points, dy by dx is going to be equal to 0. Now, if you plot this function in Desmos, you will also see that at x is equal to 1 and at x is equal to 3, the graph is going to have the turning points. You will see. You can pause the video and go and check it. You can verify for yourselves. Now, so you don't have to substitute immediately. We are going to ask ourselves that are we finished? A lot of you will think that yes, but no, we are not finished. So the biggest Cambridge mistake that students make is that so Cambridge didn't ask you to just find the x values, it asked you to find the stationary points, right? A stationary point has an x coordinate and a y coordinate, right? Both of them, right? At this any point on a curve has to be represented by the x coordinate and the corresponding y coordinate as well. So now if you have the x coordinates, you have to plug this back in here and find the corresponding y values. So when x is equal to 1, what is y equal to, and when x is equal to 3, what is y equal to? So when x is equal to 1, this is 1 minus 6 minus 5. Minus 5 plus 5 cancels and then plus 9. So this is 9, and then when it is 3, this is 27 minus 54 plus 27. So 27 minus gets cancelled and then just 5. So the other point is 5. So one coordinate is 1 comma 9 and the other is 3 comma 5. But we do not know whether this is a maximum or a minimum, or whether this is a maximum or a minimum. We don't know that yet. Okay, so the stationary points are 1 comma 9 and 3 comma 5. You can verify this on Desmos as well by writing this equation in the working space. Now this mistake alone costs thousands of students marks every examination when they don't find the corresponding y coordinates of the stationary point. Now whether this is a maximum or a minimum, so we don't know it yet, right? Now, so apparently this looks higher and this looks lower, so students may say that this is a minimum and this is a maximum, but this is a flawed logic. It doesn't work like that. Okay, so never do that. This is not the test to see whether this is a maximum or a minimum. Now in examination we don't say that it looks like, but we have to prove. So now what do? Now we differentiate again. So our dy by dx function was 3x square minus 12x plus 9 minus 12x plus 9, and make sure that you are not using the factored out version, right? Just use the actual dy by dx value or the expression. Okay, now so this is dy by dx. If I apply the differential operator again to it, right? If I apply the differential operator again to it, so this was the first derivative. Now when I apply the differential operator to the derivative again, it's going to give me the second derivative, which helps me find the nature of the turning point, right? So this becomes d squared y over dx square, right? So the denominator has a square over the entire dx. Now the differential of 3x square is nothing but 6x. This is minus 12. Now the double derivative is this, and we know that the two stationary points were occurring at x is equal to 1 and at x is equal to 3. Now let's plug these in. So the double derivative at x is equal to 1 is nothing but minus 6, and the double derivative at x is equal to 3 is nothing but positive 6, right? So this is less than 0, this is greater than 0, and by this definition this is going to be a maximum and this is going to be a minimum. Now you may ask that how does this double or the second derivative reveal the nature of a function, right? Just like because it measures how the slope itself is changing, right? So d squared y over dx square, or the double derivative, actually measures how the slope itself is changing. Just as the first derivative dy by dx or y prime right, tells you whether a function is increasing or decreasing, right? We don't know that, right? The second derivative tells you whether those slopes are getting steeper or flattening out as you move positively on the x-axis. So if you're moving like this, so if the curve is going if it's steeper, and then so it flattens out here, and then it starts going down and down and down and down. So here it becomes negative, right? So it is going to become a maximum if your double derivative at a certain x is equal to 1, or at a certain point, or at a certain stationary point is negative. That means that it's getting closer and closer. So it started steep, then it starts to flatten out, right? So this is a steep, flattens out, becomes 0, and now this is negative, negative, larger, negative, 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 right? Now similarly, if this is the case, now it started negative, started to flatten out, minus 0.5, minus 0.3, and eventually 0, and now this is increasing positively, right? So this becomes a valley. So this is a valley, right? And this is a peak. So you call it a peak, and this is a valley, right? So when your double derivative is greater than 0, you have a valley or a minimum point, or when your double derivative is less than 0, right, d squared y upon dx squared is less than 0, then you have a peak or a maximum point. Okay, now so what if your d squared y over dx squared is equal to 0? Now what does that mean? A lot of you will say that it's a point of inflection. No, it's not. Cambridge never allows that conclusion immediately. If the second derivative equals to 0, it does not prove anything. You need further investigation. Remember this. It has appeared in past papers, and we will come to that when we finish the syllabus and move on to the past papers, right? Now let's do another example. Let's say you have y equals to x power 4 minus 8x square. Now let me ask you that try this yourself. Pause the video, and then once you're done, we will solve it together. I want you guys to differentiate it. So what is going to be the differential? It's going to be 4x cubed minus 16x, right? So what's going to be the turning point? So I can take 4x common, and I will have x square minus 4. So this is going to become 4x equal to 0, x minus 2 equal to 0, and x plus 2 equal to 0, because this is nothing but difference of squares, right? So now we have got x is equal to 0, x is equal to 2, and x is equal to negative 2, right? Now so let's find out the double derivative as well, right? So d squared y upon dx squared is going to be equal to, at x is equal to 0, is going to be equal to nothing but 0, right? Yeah, so where is the second derivative? The second derivative is, so this is the first derivative. The second derivative is going to be equal to 12x minus 16. So when I put 0 here, I get negative 16. So this is a maximum. Okay, so this is a maximum. Now let's find out what happens at 2. So when I put 2 here, 24 minus 16 is positive, so this is a minimum. And what happens at minus 2? When I put negative 2 here, this becomes negative 40, so this is a maximum. Now let's find the corresponding y values here as well. So at x is equal to 0, y is 0. At x is equal to 2, y is 16 minus 32 is minus 32. And x is equal to negative 2, it is 16 minus 32 again. Okay, so 16, yeah, so 16 minus 32, so this is a minus 32 as well. So if I try to plot it, so one coordinate is 0 comma 0, the other is 2 comma negative 32, 2 comma negative 32, right? So let's say negative 32 is here and negative 2 is here, right? So I've got a turning point here, a turning point here. So the graph apparently looks something like this. Okay, so can you see that this is not a point of inflection? This is not a point of inflection. This is a proper turning point. So just if the turning point, if the double derivative at a certain stationary point, a certain x value of a stationary point just comes out to be 0, it does not really mean that this has to be a point of inflection, right? Now, I want you guys to notice something. Cambridge isn't checking whether you know calculus, whether you can differentiate, whether you know the power rule, the chain rule, or the product rule. It's checking whether you can connect algebra, differentiation, graphs, and reasoning into one complete solution so that you understand the functions properly, because this is what you apply in various disciplines. Okay, now that's exactly why these questions are worth so many marks, 12 marks, 9 marks, like even more than 10% of your total P3 weightage. So far we have only found stationary points, but differentiation can do much more. What if Cambridge asks for the equation of a tangent at this particular point, right? Let's say at x is equal to negative 3 comma something, Cambridge asks you to find the tangent. What if it asks you to find the normal of normal at this particular point, right? Whether it asks you whether the function is increasing or decreasing at a certain point or at a particular range of in the domain, that's where we are heading next. So let's start the part 2 now. Let's see that let's say that Cambridge wants you to find the equation of a tangent of this function at x is equal to 2, right? So first of all, this is a quadratic function. If I look at it, so this is x plus 3 upon 2 whole square minus 3 upon 2 is minus 9 upon 4. So minus 1 upon 4. Okay, so this, the function looks something like this. At minus 3 upon 2, it's minus 1 upon 4, and this is the minimum type. So the function goes like this. It cuts at 2, right? It cuts at 2. So the graph goes like this. Now, what if it is asking you to find the equation of a tangent at x is equal to 2? Let's say 2 is here. So the graph is going to go up like this. Now it asks you to find, it is asking you to find the gradient of a tangent at this particular point. So for this, you need the gradient here and you need the x and y coordinate. Let's say so we already know that this is 2 and this is the function value of 2. So we can find the function value of 2 by inserting x is equal to 2 here, which is going to be 4 plus 6 is 10 plus 2 is 12. So this coordinate is going to be equal to 2 comma 12, but we don't know the gradient of this tangent, right? So let's differentiate this function. So dy by dx is going to be equal to 2x plus 3. Now what is dy by dx at x is equal to 2? So that's nothing but 7. So I've got gradient 7, I've got a coordinate 2 comma 12, and I can easily find the equation. So y minus y1 is equal to mx minus x1. You can simplify, and this is the equation of the tangent, right? Now this is as easy as that, right? Now what 3 ingredients do we always need for the equation of a line, right? So it is a point, it is a gradient, and then it's the equation, right? So differentiation only give us one ingredient. We must calculate the other ourselves. We had to calculate this corresponding value of the function at x is equal to 2, which was 12, the gradient at x is equal to 2, and then plug these both into the point gradient form and find the equation, right? Now what if Cambridge asks you to find the tangent at x is equal to 1 for this function? Let's change color. Y equals to x power 3 plus 2x, right? So dy by dx is going to be equal to 3x square plus 2. So the gradient at x, so first of all, if x is equal to 1, then y is going to be equal to 3, and the gradient is going to be equal to 3 plus 2, that is 5, right? Now, so can you, now, so this is going to be equal to y minus y1 equals to m x minus x1, and you can simplify it later and find the actual and make y the subject, right? Now let's say that you want to find out the normal to the curve at x is equal to 1. So basically now let's say the curve was like this. 1 comma 3 was here, right? Let's say that this was 1 comma 3. So this was the gradient with this was a tangent with gradient 7. Now if you had to find the equation of the normal at this point, the point is going to stay the same, the gradient is going to become a negative reciprocal. So instead of 5, you're going to put negative 1 over 5. Instead of 7 here, you're going to put negative 1 over 7, right? This is as simple as that. So now let's do an example. Let's say that you have y equals to x cube minus 5x, and they are asking you to find the normal to the curve at x is equal to 2 or minus 2. Okay, so first of all, when x is equal to negative 2, y is going to be equal to 3x square. No, sorry, negative 2. Negative 8 plus 10 is 2. So the coordinate is negative 2 comma 2, and the dy by dx is going to be equal to 3x square minus 5. Put x is equal to negative 2, so 4, 3, 12, 7. So y equals to 7. So this is the gradient of the tangent. The gradient of the normal is going to be equal to negative 1 over 7. So now you plug this point into and this gradient into the point gradient form. So this is going to be equal to y minus 2. Y minus y1 is equal to m x minus x1, because x1 is minus 2, so this becomes plus, and then you simplify and get the answer. Right now, let's see how we can determine whether a function is increasing or a decreasing function. Let's say that your f prime or dy by dx is equal to 3 x minus 2 and x plus 1. Now, without drawing the graph, can you tell where the graph goes up and where it goes down? So what I'm saying is, so this is how it goes up, and this is how it goes down, and this is how it goes up, right? So this is dy by dx greater than 0. This is dy by dx greater than 0. This is dy by dx less than 0, right? So all the gradients that you draw here are going to have negative gradients. All the gradients here are going to have positive, and likewise here as well, right? So all I'm going to do is I'm going to make it greater than and less than equal to 0. Greater than and less than 0. So this becomes 3 times x minus 2, and this is x plus 1. So this is the derivative, and I equate it to greater than 0. So what happens here? So I can divide both the sides by a positive 3, so sign doesn't change. So now I have x minus 2, x plus 1 greater than 0, and because these are the coefficient of x square is positive, it's 1, which is greater than 0. So this is a minimum type curve, and we have covered this extensively in the chapter quadratics. So the roots are negative 1 and 2, and the function is going to be plotted like this. And for greater than 0, it's this range and this range. So I will say that at x is less than minus 1 and at x is greater than 0, the function is increasing. It's increasing because the dy by dx at these values, x less than minus 1 or greater than 2, appears to be or is exactly greater than 0. Right now, for less than 0, it is 3 x minus 2 and x plus 1, and less than 0. Again, I divided by 3. And again, so now I have to find the inner region. So between 2 and negative 1, dy by dx is less than 0. So this is decreasing. Okay, so this is how you determine. Now, the derivative is like a weather forecast. So let me create an analogy like that. If it's positive, the graph climbs. If it's negative, the graph falls. 0, something interesting is happening, right? And which you have to assess further. Now, another Cambridge question. Let's do. Suppose Cambridge asks you for which values of x is the function increasing, right? A lot of students will answer x is equal to negative 1 and x is equal to 2 in this previous example. It's not increasing at these values. It is increasing at greater than 2 or less than minus 1, okay? Because it is actually equal to 0 at these 2 points. Dy by dx is 0 at these 2 points, right? So beyond this, it is 2 on the right hand side, and beyond negative 1, it is positive on the left hand side, and between this, it is negative between negative 1 and 2, right? So the answer is for increasing, it is x greater than 2 or x less than negative 1, and for decreasing, it is x lies between 2 and negative 1. And stationary points occur at x is equal to negative 1 and x is equal to 2. And you can plot this function on Desmos and verify that this is the case indeed. Now, let's say that you're given a curve. Let's try to do another example to just solidify the concept in your heads. Let's say you have y equals to x cubed minus 3x squared plus 2. Now, I want you guys to solve it, differentiate it. So find stationary points, find the second derivative, find whether it's where it is increasing, where this is decreasing, and sketch it. Now, so the first derivative is going to be equal to 3x squared minus 6x, right? Now you equate it to 0 and you will find the stationary point. So this becomes 3x times x minus 2 equals to 0. So x is equal to 0 and x is equal to 2. Make sure that you never cross this variable out. This is the biggest blunder you will make in your P1 exam, and it is going to leave a very bad impression on the examiner as well, that you don't know the basics of arithmetic or algebra of algebra. Now these are the stationary points. Now let's find the d squared y upon dx squared. So dy squared y upon dx squared is going to be equal to 6x minus 6. Now if I put 0, it's so this is negative, so this is nothing but maximum, and when I put x is equal to 2, this is positive, so this is a minimum. And what is the corresponding values of y values at these stationary points? So this is 0, so this is maximum 0 comma what, and this is minimum 2 comma what. So when I put 0 in here, this becomes 2. When I put 2 in here, this becomes 8. Minus 12 is minus 4 plus 2 is minus 2. So 0 comma 2, 2 comma minus 2, this one is maximum, this one is a minimum. Now let's find where it is increasing and where it is decreasing. So dy by dx, which is 3x squared minus 6x, is greater than 0. So this is going to produce the range where the function is increasing. So I take x common, 3x common, so this becomes x minus 2 is greater than 0. So now this is a minimum type curve. So this is 0, this is 2. So greater than 0 is this or this, right? So for x is less than 0 or x is greater than 0, the graph is increasing. And between 2 and 0, the graph is decreasing. Okay, so this is what it is like. Now, what topics did we just combine? We combined functions, differentiation, graphs, stationary points, reasoning. This is exactly how Cambridge writes its long questions. Now, I want you to notice something. Cambridge isn't testing whether you can press buttons. It's testing whether you understand the relationship between a graph, its gradient, its derivative, and finally its equation, right? Everything we have done today comes from one idea, the derivative. Now we have learned stationary points, tangents, normals, increasing, decreasing functions, but the most famous application of differentiation is still left, that is optimization. How to maximize profit, how to minimize the cost, how to find the largest area, how to find the fastest route, and finally one of the most beautiful ideas in calculus, related rates. Let's finish this chapter exactly the way Cambridge asks it in P1. Now, what do I mean by optimization? Let's say that your revenue, your total revenue of a certain company, where this is quantity, and total revenue, you get total revenue by price multiplied by quantity, and price is a function of x and quantity is a function of x. Let's say it goes like this. So as you produce more, your total revenue climbs up, and up all the way till here, and then eventually it starts to go down, right? Or maybe the total revenue is going like this, right? And the total profit, as you increase, it may go like this, right? So we are saying that as you start to increase, so this is an increasing function, by the way, there is no dip. It's getting flatter and flatter, but nonetheless it's increasing. Now total profit is increasing, and it comes to a tipping point, right? So how do you find this point? Because you want to find the optimum quantity Q naught at which you are maximizing your profit, because any additional unit that you are producing is now contributing negatively because of some economic losses or some inefficiency that's kicking in owing to the increase in the volume of production, right? So at an optimum value, your total profit is getting to the maximum, and you want to find it out. So how do you do that? You differentiate the total profit function with respect to the quantity, and you equate it to 0, and at whichever quantity you get the answer 0, that's where the profit is maximizing. So now let's do it. Now optimization by definition, it is to find the best possible value. Find the best possible value. Okay. Now, Cambridge Heights optimization inside words. The mathematics is never difficult, the English is. Now, let's say that a rectangle has perimeter 40 centimeter, right? So, for some length and for some breadth, the total perimeter of this 2 times L plus B is 40. Okay. Now, find the maximum possible area, right? So, how do we find the maximum possible area? We know that area is equal to length into breadth, right? So, first of all, let's, so this is 2L, or rather L plus B is equal to 40, or L is equal to 40 minus B. So we just defined length in terms of breadth. So area is now going to be equal to, instead of length, I'm going to write 40 minus B, and the breadth is just B. So area is nothing but just a function of this breadth, 40B minus B square. Now, if I differentiate the area with respect to B, this becomes 40 minus 2B. And now when I equate it to 0, this is going to give me B is equal to 20. Now, if I take the breadth as 20, the breadth as 20, really? Oh, sorry. This is not 40B. Oh, sorry. This was 20. This is where I got confused, because we divided both the sides by 2, right? And this becomes 20 minus B as well. So this is 20, this is 20. 20B minus 2B squared, and this becomes, no, when I differentiated it, this becomes 20 minus 2B. So now B is equal to 10. So if my breadth is 10, so if this is 10 and this is 10, then definitely this is going to be 10 and 10 as well, because the total, so once you turn it into a square, that's where you get the maximum area, which is going to be 100. Now, if you make any other combination, let's say you take this as 11, this is 11, and this is 9, and this is 9. So now the area is going to be 99. What if you take this as 8, this is 12. So now this is going to be equal to 96, right? So the maximum area that you can get is when this is 10 and this is 10 and this is 10 and this is 10. Can you see the beauty of differentiation and the optimization? So this is what optimization does. Now, so the recipe here is that you convert everything into one variable, just like we got rid of the length and just had it in terms of width or the breadth, right? B. And then you differentiate, and then you find the stationary point, and then you do the second derivative and interpret the answer, right? Now, this, if you create a flowchart of this, that you have to do one variable, then you differentiate, then you find a stationary point, then you find the area value or whatever metric is, whatever the main function is, and then that's the answer, right? Now, let's do another optimization problem. Suppose the cost function is a function of quantity which is denoted by x is minus 18x squared plus 48x plus 15. Now, if you have to find the minimum cost, you have to find the minimum point where the double derivative has to be greater than 0, right? So let's find the first derivative. So that is 6x squared minus 36x plus 48. And if I take the stationary point, I equate it to 0, take 6 common, so this becomes x squared minus 6x plus 12, no, plus 8. So 4 2s are x squared minus 4x minus 2x plus 8 equal to 0. Don't worry about my writing. The concept should get in the head. Nothing else matters here. But neither am I saying that your writing has to be as miserable as mine, but I'm just trying to stay within the time limit for the YouTube lecture. I don't want you guys to play it and multiply by 2.5 or something. I want the speed to be some optimum level. Now, at x is equal to 2, what is the double derivative? So that's going to be equal to, so first of all, it is 12x minus 36. Now, the double derivative at 2 is going to be equal to 24 minus 26 is minus 12 is less than 0, hence maximum. So this is the max cost that you can attain at 2 units. And minimum cost is going to be at 4 units, which is, I don't know, these may be airlines or something, right? or the units could be in thousands or tens of thousands, right? So at 4, this is going to be equal to 48 minus 36 is plus 12, which is greater than 0 and hence minimum. And we have already done earlier in the lesson that why does maximum and minimum reveal the nature, right? So we have to find the minimum cost. So the minimum cost occurs at x is equal to 4. So put this 4 in here. So this becomes 2 times 64 is 128 minus 18 times 16. Wow, whatever that is. I'm not calculating it. 48 times 4 is 192 and then plus 15, right? So this is going to give you the minimum cost, right? So that's the answer. Now let's do the last thing, which is the related rates. Now this is probably the most beautiful application of differentiation, which is related rates. Okay. Now let's say that there's a circle. Okay, we have a circle. Now let's say that the radius is increasing, right? So if radius increasing, the area is also increased, right? That's just very common now. Now suppose radius increases at, so radius is increasing, which means that radius is changing with respect to time at 2 centimeter per second. Every centimeter radius increases by 2 centimeter per second, right? Now find rate of increase of area when r is equal to 5. So at a particular r, which is at 5, find out the increase in the area, right? Now, so area is nothing but pi r square, and the derivative of area is going to be equal to 2 pi r, right? Now area is changing, which means that we have to find dA by dt, which we don't know, but we can create a chain rule again, dA by dr into dr by dt, right? We have to find this. We don't know this. Let's keep it as it is. We do know dA by dr, which is 2 pi r, and dr by dt is 2, right? And we have to find it at r is equal to 5. So 5 times 2, 10. 10 pi times 2 is nothing but 20 pi. So area is increasing by 20 pi centimeter square per second when r is equal to 5, and add dr by dt of 2 centimeter per second. You also can rewrite it as 2 centimeter per second, right? Make sure the unit is squared. The centimeter is squared when you're talking about the area, right? Now this is why the chain rule exists, not because Cambridge likes making life difficult, because nature changes everything simultaneously. It's not like a variable is constant, the other variable is changing. Every change in one variable creates a change in several other variables, but we just deal with two of them. Now let's solve a real Cambridge style question. Let's say that the curve is y equals to x cubed minus 6x squared plus 9x plus 2. Find the coordinates of all stationary points. So in part A, you just find dy by dx equated to 0. So this is 3x squared minus 12x plus 9. You just find the x values, x1 and x2, right? Now determine the nature of each stationary point. You have to find the double derivative at these x1 and x2, right? x1 and then at x2 as well, right? If it comes out to be less than 0, it's a maximum. If it comes out to be greater than 0, it's a minimum, right? In part C, if the question asks you to find the equation of the tangent, right, at one of that, so you just need to find the gradient, the dy by dx at this particular x1 or x2, wherever it asks you to find, or maybe at any other point. Let's say x is equal to 2, because at these points the dy by dx ought to be 0, right? This is how we calculated these, by equated the derivative to 0. Now if you have to find the equation of a tangent, you're going to find the corresponding value of y at x is equal to 2 and the gradient at x is equal to 2, and then put it in the point slope form. Now if in part D it asks you to find the equation of the normal at the same point instead of the slope, whatever you calculate, you just do the negative reciprocal. In part E, it may ask you to determine the intervals where the function is increasing. So dy by dx is greater than 0 and find the interval. We have done the inequalities earlier. And if it asks you to sketch the curve showing all important features, you show where the curve is increasing, the stationary points, the nature of those stationary points, the x-intercepts, the y-intercepts, and all of that, right? So it may ask you such a question for 13 marks or 12 marks, right? So you can do it yourself and comment the answers in the comment section, right? Now, this is exactly how Cambridge combines multiple learning objectives into one long question. Notice something, there wasn't a single new formula. Everything came from one derivative. A lot of mistakes that students make is that they forget the corresponding y coordinate. They just find the given x coordinate and they do not put the corresponding y coordinate. They forget to find the double derivative in order to determine the nature of the turning point. They use the negative instead of negative reciprocal for the normal. For normal, this is the gradient, right? Negative reciprocal. They use the wrong point in the tangency. They may use the point of the turning point, right? Whereas the tangent may be required to be found at some other point. They may answer stationary points instead of intervals. Between stationary points, because between the stationary points the graph changes natures. So this is the stationary point. So here the graph is increasing, right? And after this it starts to decrease, and here it is decreasing, right? So do not give these answers, give the range between them, right? Forgetting interpretation and optimization. So in a cost function did you see that we discarded 2 and we used 4, because at 4 the double derivative came out to be less than 0, came out to be greater than 0, and hence it was a minimum type, right? So at 4 units we were obtaining the least cost, okay? And finally they use the derivative instead of original function. In order to find the value of y, you have to put the value of x in the original function. You don't have to put this x naught in the derivative function. That's going to produce a 0 if that's x naught is for a stationary point, right? So my final advice is that if you're sitting in the examination hall and differentiation appears, do not panic. Ask yourself one question: what is Cambridge actually asking me to do with the derivative? Once you answer that, the entire question starts solving itself. So in conclusion, today we officially finished the entire chapter of differentiation. So half of calculus, which is differentiation, is now done. We did the limits implicitly through gradients. We did the differentiation rules, product rules, chain rules, power rules. We did the stationary points, maximum, minimum, tangents, normals, increasing and decreasing functions, optimization, related rates, and Cambridge mixed questions. So this is an enormous part of P1 which we completed. Now what's next? We move on to the final chapter of the entire AS Pure Math series, which is integration, and this is the final chapter. And by the 24th of July, as we predicted and as we decided at the start, we will be completing the entire lecture series on YouTube. And here's something exciting. Cambridge is often called the opposite, integration is often called the opposite of differentiation, but I don't want you to think of it that way. I want you to think of it as the answer to a question differentiation cannot answer. Differentiation asks how fast is something changing. Integration asks, if I know how fast something changes, can I reconstruct the original function? Right? That's where we'll begin in the next lecture. And once integration is complete, you'll have officially covered the entire 9709 ASP1 syllabus. After that, it's all about Cambridge past papers, examiner thinking, and converting knowledge into A and A star grades. If today's lecture helped you understand differentiation, not just memorize formulas, give it a like, give it a thumbs up, subscribe to this YouTube channel on Easy Taleem, and share it with someone preparing for CAIE Mathematics, and comment whether you like this or what you liked about it or disliked about it. If you want to enroll in our classes for October, November, or May, June, we are going to be starting our crash course for the October, November 26 series for AS and A2 Mathematics from the 11th of August. A lot of you are going to decide that. And for May, June 27, we are going to start from the 1st of August, right? You can reach out to me on my on our Instagram, where we go by the handle EASYTALEEM, Easy Taleem. I want you guys to do the practice from your Cambridge endorsed black cover book as well. If you don't have that, you can reach out to me on my WhatsApp +92 329 3028 485. You also want to you must also follow our Instagram channel because of all the save worthy carousels and posts and reels that we post here. So make sure that you're doing that. I'll see you guys in the integration chapter. Allah Hafiz.